Yeah, hello all. My name is Vipin Jain, and I am talking from India. So we are like many thousand miles apart. So good to see you guys from the other part of the world. I work for MetaCube Softwares, which is located in the pink city of India. This is similar to the background of your conference slides. Many houses are colored like this. And I will be speaking about vaccinate your software and build its immunity, which is basically about chaos testing, or in other words, testing on production. So, who am I? So, I am a son, husband, and a father. You can see my family pic here. Uh, my wife, my daughter, and my son. I am a tester at heart. It's close to 20 years now into software testing. Uh, I'm speaker by choice. So started international speaking in 2012 in Spain, and till now, including this conference, this would be my 35th international conference. Uh, I work as a head QA and delivery at MetaCube Softwares. I love processes. For large clients, I always take pride in setting up the process for smooth deliveries. And since last year, I also became a blogger. So like about 30 blogs published all over the internet. And here are some of my connects. So you can interact with me on LinkedIn, Twitter, and you can send me email as well. So that's about me. Moving forward, have you seen any picture like this sometimes in your house or at your office or some other place? This is a real world chaos. There is no system in place. Everyone is rushing. There are no queues or nothing. So that is what we actually termed as chaos in simple English language. How, first of all, how to see this chaos into a system, into a software system. And then, of course, we will see how we handle this chaos situations as a software testers. So let us first see what exactly is chaos testing, or in other words, chaos engineering. So chaos engineering, it is a highly disciplined approach. It helps us in testing a system's integrity by proactively simulating and identifying failures in a given environment. Uh, just think of a vaccine or a flu shot. So you inject yourself with a vaccine with a small amount of a harmful foreign body, and that helps to build resistance in your body and prevent illness. So chaos engineering is a tool that we use to build such an immunity in our technical systems by injecting harm. And what is the harm in terms of softwares? Like latency, CPU failures, or a network black hole, anything which can make the system stop. And then we use this to find out and mitigate, basically remove any potential weakness. So this is a crux of chaos testing. And now I'll take you into some details. Let's begin with a little history of chaos testing or engineering. So in 2010, this term was born. So still chaos testing is not a very old testing methodologies like agile or black box or performance testing. It is a very new testing. So in 2010, the first time the term was coined, and it was designed by Netflix. So you know Netflix, right? We all watch a lot of movies on Netflix, and they designed this tool called as Chaos Monkey to test their system stability by enforcing failures via pseudo-random termination of instances. So this tool, what it does, it just goes inside the Netflix entire server infrastructure, and it randomly terminates any system. And then the engineers see what stoppage of that particular system, what is the impact on their entire Netflix infrastructure. When we test, we always test in a sequential way, right? We start A, we stop A, we go to B, then do B, and something like that. Uh, imagine a situation where you put a monkey inside your room, lock the door, and then you cannot instruct the monkey like what are the steps it should take. It can jump on your computer table. From there it can just open the refrigerator. It can jump on your bed. In any way it can go. And after 15 minutes, take the monkey out of your room Go inside and see that whatever things the monkey has touched, whether they are still working or not. If they are working, that means they are resilient. If they are not working, then you have to make those things strong enough so that next time when the monkey comes in, that things don't break. Exactly, this is the scenario what Netflix thought of, because they wanted their customers, people like you and me, to have a seamless experience while watching a movie. So Chaos Monkey is responsible for randomly terminating instances in the production to ensure that the engineers implement their services to make resilient and to ensure that no further failures happen. This is 2010. Within 1 year, 2011, there was an entire simian army was born. So there was a Chaos Monkey, there was a Janitor Monkey, there was a Chaos Kong, Latency Monkey, Doctor Monkey, Security Monkey, Chaos Gorilla, you name it. So they all help Netflix to become very, very strong in the deliveries. And people like you and me, again, wherever we are sitting, I am on, let's say, a 3G internet, or you are on a 5G internet, broadbands, telephones, whatever device you are watching the movie always comes seamless. Unless you have a very bad internet, the movie breaks up. Otherwise, the movie is always very smooth. And how they were able to achieve this? By introducing chaos engineering. And within 9 years, 10 years, what happened? In 2020, chaos engineering has now become part of the AWS well-architectured framework. So every year, this WAF, they announce a new addition to their systems. And in the 8th update of their system, chaos engineering is become a requirement for a reliable system. So if you or your company are actually making a service which is catering to the people across the world, not just into your city or your country, it's across the world, distributed systems, and which requires a lot of internet and cloud infrastructure, chaos engineering is mandatory. And if you are using AWS for that, then you have to make sure that your chaos engineering tests pass. That's a brief history about this chaos testing. Now, because it is very well architectured, there were very clearly defined 5 steps to build your chaos testing approach. So you have to build a hypothesis around a steady state behavior. You have to vary the real world events, run the experiments in production, automate your experiments, and then you have to reduce the blast radius. And I will take each one of them in my next slides. So let's first move to how to build an hypothesis and what does it mean. So this blank space, right? This one. Under dash circumstances, the security team is notified. Now, this is a simple situation. The dev teams, the QA teams, the business holders, they all will sit together and they say that, okay, the blank space is filled by a variable that the team determines. This emphasizes building your hypothesis around a steady state definition. This means that we know what the system is expected to behave and we need to capture that as a measurement. So you have an idea of what can go wrong, right? You have chosen the exact failure object. So what would happen next? This is an excellent exercise to work through as a team. And once you are done with this, entire team, from your stakeholders till the QAs, they know that what would happen, under what circumstances we should be notifying the security team. So how we go about this? Let's say every team we all discussed, and this is the final result. Under security control violation circumstances, the security team is notified. So this is the first variable which we basically keep track as a measurement. And then we always track that, okay, this has happened. So we have to notify the security team. And if the violation is not on security, then there is some other way to do. So we keep building these hypotheses and make sure that everything, all the steady state behaviors are noted or recorded. The output would be a document, or let's say a big sheet of all such circumstances, all such hypotheses and solutions, and the entire team knows what to achieve. This is step number 1. Then you have to vary the real world events. Now, what does that mean? So this principle states that the variables in your experiment should reflect real world events. Like the previous slide, what was the variable that we used? Security control violation. Now, these variables have to be some real world events. Now, security control violation is a real event. There are people who are trying to gain access, unauthorized access to your systems. So we know that the security is basically compromised. So all these variables have to be very thought of. You cannot just take any variable. So while this might seem obvious, you will say that, yes, Vipin, we will only take variables that we need. But there are two good reasons why I have put this thought here. First, variables are often chosen for what is easy to do rather than how much value it gives us. So like developers, they just see, okay, these are the variables. This is easy variable. I can reproduce that into my system. Let's take it. Sometimes we only take variables which reflect our experience as testers and not the real world user's experience. So which means either we take all the variables or we take sometimes very selective variable, but don't decide on which one. So this image basically gives you like you can pick any variable that you want. And this image shows that you can pick all the variables. Both these approaches are wrong. You have to make sure that pick only those variables which affect the real system, which affect the real users, as well as which gives value to your experiment. So don't just go for all the variables or any variable. You have to be very selective about what variable you want to select. Then we have to test in production. So tonight we test in production. That's like a war, right? Your management will just say, no, we won't allow it. Come on, I have to test on production. I have to see a lot of things, but then no one is allowing us. Why? Because experimentation is required on the system that you are testing. Now, when you do experiments on your staging environments or QA environments, then no one complains because that is not the production. But what is the output of experiments? The output of experiments is you build confidence into that environment. You say, okay, my staging is working fine. My services are talking to each other. The APIs are working fine. The results are coming correctly. But when you put the same code on the production, we always are in a doubt whether everything works perfectly fine or not. And often after doing a major release, there are certain production bugs that gets generated and the customer always complains. But the problem with us as testers is we cannot test on production. We are not allowed to test on production. So what we do, we generally take a mock of the entire production, a dump, and we create the staging out of it. But there are situations, there are data streams on the production which we cannot think. So while we try to test the best we can do on the staging, but still there are situations where we cannot think or cannot predict what would happen on production. That is why the chaos engineering takes place only on production. So as I said, it is a war and you have to fight it. You know what is this? This was one of the first tests on production. What we are testing? We are testing a bulletproof life vest. How it would be tested on production? Someone will wear it, someone will try to take a shot, and then we make sure whether the guy is alive or not. Now, replace this guy with the production system. And the guy who has the gun in the hand, he's the tester on production. If you try to take a shot on the production system, anything can happen. The entire production server can go down. All your customers across the world, they start complaining. You will lose business. But if you don't do this kind of testing on the production system, then there will be bugs which still can take your system down. So better to test and make sure things cannot go down rather than feel sorry later. You have to automate your experiments. That is again very, very important. And why it is required. So we know that automation provides a mean to scale out right? What you want to exactly scale out here? You want to scale out the search for the vulnerabilities that could contribute to the undesirable systematic outcomes. And we also want to ensure that our assumptions over the time are correct and unknown parts of the systems are changed. So we have to cover a large set of experiments that humans can cover manually. Now, in complex systems, the conditions that could possibly contribute to such an incident, they are so numerous that you cannot basically plan for them. So then manual user cannot focus on each kind of situation. This thing will be tackled by automation. So you have to make sure that a lot of automation is also put into the place. Then how will you proceed further? You have to keep the blast radius as small as possible. What do you mean by the blast radius? My testing on the production system is my responsibility. And I have to make sure, I have to be very clear that if my test fails, which API or which system or which module in the production will be affected. So I say that my test can create a blast, but the blast should not be big that it just destroys the entire production system. So as this image depicts, a blast happened, but only one building is going down and rest everything around it is working perfectly fine. That type of planning, that level of planning has to be required before you do any experiment on the production. In staging, we are fine. We just try to put anything that we want because we know that maximum what can happen, the system goes down, but it will not affect any single real life user. But we cannot do the same thing on the production because it can affect all the users. It can cost your company billions of dollars loss. It can it can destroy a complete business, right? So we have to be very, very clear about how we reduce the blast radius to as minimum as possible. And then you have to build something called as knowns, unknowns matrix. These are the execution rules, basically. So known and unknown on the left-hand side, these are the things that we are aware of or things we are not aware of. And on the x-axis, the known and unknowns means things we understand or the things we don't understand. So when we see number 1, this is known, knowns. That means things you are aware of and you understand. Similarly, known, unknowns, things you are aware of but do not fully understand. Unknown knowns, things you understand but you are not aware of. And then unknown unknowns, neither we know about nor we understand. So this type of matrix we have to create. And once I take an example, then you are very, very clear about what this matrix will help you in achieving your targets. Let's take the scenario. What this scenario is. In this scenario, there is a region A which has a primary node or primary database, and the primary database has 2 replicas, and both the replicas are created by replicating the primary node directly. Simple. Then we also have a region B, a different place. The primary is also replicated into a pseudo primary, and replica 1 and replica 2 are also converted into pseudo replica 1 and pseudo replica 2. So just remember this figure. So you have a primary database and 2 replicas of it, and this entire structure is again replicated. Okay, now let's start building our chaos engineering experiment. So let's set up the knowns, unknowns. What is the known and unknown, known and knowns? So we know that if a replica shuts down, right, then it will be removed from the cluster. So let's say the replica 1 in the original database, right? If it shuts down, we just remove it from the cluster. A new replica will then be cloned from the primary and added back to the cluster. So if I just go back, if this replica 1 shuts down, we remove it from the system and we make another replica of primary and put it this place. We know about this and we are understanding this feature also. So they become our known knowns, right? Let's go to the second one. Known, unknown. The clone will occur. And why we know this? Because if I see the logs, I can clearly see whether the log has a success message or a failure message. So whether the clone making was successful or it was a failure. So this is the known to us. But what is unknown? The weekly average of the mean time it takes from experiencing a failure to adding a clone successfully. How much time it takes, it is unknown. Whether it takes like 5 minutes or it takes 50 minutes or it takes 5 hours. And what is the mean average? This is unknown. That's our second experiment. Then unknown knowns. What would happen if both the replicas get shut down? If we shut down the two replicas for the cluster at the same time, then we don't know exactly the mean time it would take to clone the two new replicas of the existing primary. We never thought about this. We said that, okay, if replica 1 goes down, we created another one. If replica 2 goes down, we create another one. What would happen if replica 1 and 2 both get shut down at the same instance? Can my primary will be used to create two replicas at the same time? If not, then what is the time between first replica and second replica creation? Is my primary can even create two replicas? We don't know. But what we understand is we have a pseudo primary and two replicas. So all my transactions, all my real life business transactions will be moved to the pseudo ones. So the customer who is outside using my system, he will not realize whether some replicas got shut down, because for him the transactions are going smoothless. The transactions going smooth, right? So this is the unknown and known. And what are the unknown and unknowns? Neither we understand nor we know about them. What would happen if we shut down an entire cluster in the main region? So your primary, your pseudo 1 and your pseudo 2. Your primary, your replica 1 and replica 2, all three get shut down at the same time. What would happen? Similarly, will the pseudo region be able to fail over effectively because we have not run this scenario? So in this case, whether my entire system goes into the pseudo or only the replica gets replaced by pseudo replica, like what would happen? We are not very sure about this. So this becomes my unknown unknowns. So these are the different situations we create our matrix. Now, once you go through all these things, one big thing that you also have to do, which I have not put here in any slide, but I want to discuss that, is you have to convince your management also. The management generally will not allow you to do any chaos testing. First, it is not that popular, right? If you are working on a product which does not have a huge user database, there is no point running chaos testing. It generally goes for large systems which is being accessed by millions of users, like Amazon, for example, or Netflix, like our example that I just took, or Spotify, where you hear music in your country. So these kind of applications which have millions of users across the world, and all those globalization and localization techniques are employed on these. Chaos engineering basically is a thing that needs to be tested there. It is a very interesting thing, but yet it is very risky thing. And because of this risk, there is a reputation risk. If Netflix continuously goes down every day, you will stop using Netflix and you might go to Amazon Prime. Similarly, it's a reputation risk, number one. It's a financial risk because users will just stop buying the service, and it's like millions of dollars again. And similarly, the other competitors, they will become very strong in the market. So you will lose reputation, you will lose money, you will lose users. That is why the management generally won't allow doing this kind of thing. So you have to explain to them why it is required. And the best explanation that you can use, the arguments that you can use, they come now on this slide. So what are the benefits? This is a slide that you can basically take to your management if you want to do any kind of chaos testing. First, the customers will be happy. Why? increased availability and durability of service. This is the output of chaos testing. There are no outages that disrupt their day-to-day lives. Okay, that's the first one. Then the business. The business will prevent big losses in revenue and maintenance costs. The businesses are happy because the engineers are more engaged. And the most importantly, your support systems, the incident management systems, they will improve a lot, because lots of situations which the customers will actually call you and say that they are not happy with your service, we already catch them while doing the chaos testing. This is the business aspect. But then your technical teams, there are a lot of insights, which means incidents will reduce. Engineering team already know that, okay, this thing is can happen on the production system. So they are already aware about that. Their increased understanding of the system failures, which ultimately will improve the incident management system. So less stress, happy customers. When customers are happy, more customers will come, which means the business will become happy. So you can take this slide, go to your management and explain that why you need chaos testing. Now, this is very interesting slide. We are almost at the end of our slides. These are the distributed system fallacies. Whenever you are using any distributed system, like for example, again, we take example of Amazon shopping or Netflix. There are few things which we always believe as an end user, as a user of the system. We always believe the network is reliable. When I watch a movie, it never comes in my mind what would happen if network breaks. I just believe that, okay, yeah, I'll just watch this movie today. And then I just start. The latency is zero. There is no break between the movie. The network is secured. Topology doesn't change. The network is homogeneous. Transport cost is zero. There is only one administrator. So if any problem happens, he will resolve it. There are no multiple administrators. These are certain fallacies which we believe that whenever I am using these services, everything would work fine for me. But what is the real life scenarios? These fallacies, they drive the design of chaos engineering experiments. Like what would happen if there is a packet loss? What would happen if there are latency attacks? For example, network outage can cause a range of failures. Applications may stall while they wait endlessly for a packet. There is everything gets freeze on your machines. Applications can permanently consume memory or any other resource. And when an outage has passed, many applications, they fail to start from exactly the same situation. Just imagine a scenario where you are watching a movie and you reach like about 50% of the movie and a network outage happened. And then there is no way to start the movie from exactly the place from where you stopped last time. Just imagine this scenario. So you can start the movie from exactly the same place where you stopped last night. How these things happen? And you are not one user for Netflix. There are millions of users watching the same movie and who stop that movie at a certain point. When you log in the next day, you will receive your movie exactly from the same point. These kind of things, just imagine the type of testing you require. Is it a functionality testing? Is it a manual, simple load balancing testing, performance testing? These are the chaos testings. These are the outputs of lots of chaos monkeys problems, which the engineers found, and then they create code around it. And then now we are looking the brilliance of that code, the outputs of that code as an end user. Fine. So ultimately, I just want to take you to a quick summary page. So remember, no system literally is 100% safe from any outage. Internet can go down anytime. We can certainly have some control over the impact on partners, employees, customers, and business reputation, but it is only some control. To have a larger control, you have to have chaos engineering in your place, because running the chaos tests, it minimizes the number of crashes. I am not saying it will remove all the crashes, but it will minimize the crashes or your system failures in production, as long as the QA testing or your DevOps teams are involved. with the in-depth knowledge, like when something can break, proper tools like Chaos Monkeys and the Simian Army, cooperations, collaborations, and pragmatic cooperation between team and team members, there is no reason why the organizations cannot leverage the power of chaos testing and in turn reduce the chances of your system's failure across the world. With this, I come to the end of my slides. Thank you, and I'm open to any questions.
Hi, can you hear me?
Yes, I can hear you.
First of all, thank you very much. It was very interesting information. I have a small question. Where is a point on which chaos testing would not be relevant, user number wise? You said millions all over the world. It's a must. Small, soft, no need. But what about middle ground?
Maybe millions. I've said little bit more. It can be few hundred thousands.
Starting
Right? But
with
if you just have like thousand users, or let's say 2,000 users or something, I think the performance test or the load test, they become much simpler. But there is one definitely point. If the system is a mission critical system, if the system is a very critical system, even if it has like just 2,000 users, we cannot afford the system to break at any time. And I again give you a real life example, which comes from one of my projects. So we are developing the IoT systems for an online insulin injection system into a medical company, right? So diabetes, you all understand, that's a disease which is like spread across the world. So there is a small chip that we have developed, which we put into a person's stomach, and then you can just wear your dress and you just go anywhere. And this chip is basically continuously keeping track of the sugar in your blood levels, right? There is no pain, nothing would happen. But you have to have an phone, internet enabled phone into your hand wherever you go. Now, assuming the sugar level goes down, so the chip immediately sends a signal to the phone, and through the phone, it goes to 5 of your relatives, like your parents or your kids or anywhere. It goes to the nearest hospital. It goes to a doctor, like he may be millions of miles apart sitting, but he will receive a notification on their mobiles. So lots of people around the world, they know that this particular patient has a low insulin level. Now, what would happen? The doctor from his place can click a button, and the chip, it also has a very small needle which has like about a very small amount of insulin, and it gets inserted into the patient's body immediately. Now, in this scenario, it's a life-saving system. It's a very critical system. So it doesn't matter it has only one user, doesn't matter it has millions of users, right? We cannot afford to such a system go down. And that is where this kind of testing is required.
Thank you very much. So to draw the line, if system not critical, life critical, so it starting with two couple of hundred thousands users.
Yes, so critical systems or simple systems, but with a very large user base.
Thank you.
Thank you. That's a good question, in fact.
Some more questions? I also have one question about latency. If we test and discover the latency in only one region, let's imagine that we have the application that is like worldwide spread. So there are like different users in different countries. And if the latency happens only in one country, for example, what would be the next steps for the tester?
So that again depends on your, the terms I use, globalization and localization. If the latency in one country is low, how the system infrastructure is built up, that is the important thing. Are we controlling the entire infrastructure from one central place, or there are like various regions? Like, so I believe Netflix is not controlling the entire streaming from one single server. So it has a larger cluster, then they have small clusters in different places. And that's why when I log into India in my Netflix, I see all the movies listing in Hindi, which is our national language. But when I take the same computer, like last week I was in US, and when I take the same computer and I just logged in my Netflix account in California, right? All my Hindi movies were gone, and I was seeing all the latest US movies there. And I'm pretty sure if I was speaking this lecture in Moscow with you guys, I would be possibly looking at a lot of Russian movies as the first thing. So if it's a country specific or location specific problem, I think country specific solutions will be there, and latency may not be like a country specific. It may be your service provider. It may be like you are using that on a mobile. Although the signals are great, but you are, let's say, in a remote place, you are in a village or something where net is not that strong. You may be on a mountain doing some hiking, or maybe near a seashore or something. So there are lots of, I would say, factors that could help that could basically cause that latency problems. But your service provider or the application like Netflix, that is not responsible for that problem. But if Netflix is causing that problem, if the latency is coming from Netflix side, some big problem has happened, then you can always say that, okay, their testing failed, and they will ensure that this thing won't happen again. And this entire monkey suite, I think this 30-minute was very less. If this would have been 1 hour or something, I would have actually opened up the Chaos Monkey tool and showed you a lot of things there. Maybe next time, next year, I'll just have a presentation on how Chaos Monkey works.
Okay. Yeah, thank you very much. Actually, we really need it, especially from like at my work. It's much needed. Thank you.
You can always contact me.
Yeah, I will. I will definitely ask
something
you about this model. Thank you.
Sure. Thank you.
More questions? Okay. Thank you very much.
So this is my second time online. I couldn't come last year. I couldn't come this year due to various reasons. So I'm sure third time it will be in person. Thank you.